Okay, this is another problem from my ASM study manual on variance of loss at issue. It's another continuous problem. It's a little bit more interesting, but still not horrible. So they give us that if premiums are determined by the equivalence principle, the variance of the loss at issue is 0.1073. They give us the second moment of our whole life insurance payable at the moment of death on X. They tell us that that's 0.1. And then they say for the actual contract premium P, so if premiums were determined by the equivalence principle, the variance would be this. But they're not. They're actually some other amount P. And for that actual contract premium, the expected loss at issue is negative 0.1, which means that we made 0.1. And they would like us to calculate P, our actual contract premium, over delta, the force of interest. So the first thing to start with here, let me go ahead and erase this. I know that if premiums are calculated by the equivalence principle, our variance turns out to be the second moment of our whole life insurance minus the actuarial present value of the insurance squared over 1 minus the insurance quantity squared. This is not something that I memorized. This is something that I know and understand from working it out so many times. So don't memorize this. In the previous video, I show you how you can work it out using what you already know. But assuming you've gotten this far, what we can do here is, right, they give us that the second moment is 0.1, so I can plug in 0.1 and then just solve for the actuarial present value of my whole life insurance. You can simplify this down into a quadratic equation, which should be 1.1073 times the insurance squared minus 0.2146 times the insurance plus 0.0073 equals 0. So I'm skipping all the work in between there because I'm confident that you already know how to do that. And then you can use the quadratic formula to get values for your variable here, which is the insurance. When I did that, I got 0.0440 and 0.1498. And at first I was thinking those are both valid values for the insurance. They're both between 0 and 1. How do I know which one to use? The thing is, they gave us that the second moment of the insurance was 0.1, and you know that that has to be less than the actuarial present value of our insurance. If you think about that, it makes sense, because a lot of times, you're calculating the second moment of this insurance. You can calculate it the same way as the actuarial present value of this insurance, except at twice the force of delta. So if you're doing the same thing, but at a greater rate of interest, it's going to be discounted. It's like it's getting discounted back farther, and your present value is going to be smaller. So since the second moment of your insurance has to be smaller than the actuarial present value of your insurance here, we know that this won't work, and we'll have to use 0.1498. So once we have our A bar X, the actuarial present value of our continuous whole life insurance on X, we remember that they told us the expected value of the loss at issue was negative 0.1. Now, Here, premiums are not calculated by the equivalence principle, but we can still use what we just found about the insurance, because that will be the same whether premiums were calculated by the equivalence principle or not. So the expected value of our loss at issue will be the actuarial present value of the insurance minus, they told us that the actual contract premium is P, so I'll use P. So it's the insurance less the present value of the premiums that you bring in. So which is going to be P times our annuity. I'll plug in my 0.1498 for the insurance, and I'll rewrite my annuity in terms of the insurance since I know what that is. That'll be over delta since it's continuous. Of course, I can pull out my P over delta here. I suppose it would have just been easier to do the 1 minus 0.1498 first, but oh well. Either way, this is just algebra now. And you can solve for P over delta. And I got 0.2938. All right, and that's it for that one. Happy studying.